now a block on an inclined plane moving down the plane because of an applied force. Now the applied force is in the downward direction, so the applied force is in the same direction as the parallel force. That's opposing the force of friction. We're only going to look at the forces along the plane. We're not going to bother with Fn or F perpendicular because they're opposing each other. The block isn't moving up and a block isn't moving in. So the sum of the forces in the x direction will be equal to force applied plus force parallel minus force of friction equals ma. Alright, now we showed earlier that F parallel is equal to mg sine theta. So force applied plus mg sine theta minus force of friction was equal to mu mg cosine theta. That equals ma. Now we can just move these over to the other side and get force applied. Force applied is going to be equal to mass times acceleration plus mu mg cosine theta minus mg sine theta. And that solves for force applied. If you wanted to solve for acceleration, you basically go from this equation and divide by mass. So we're going to do that. Acceleration would be equal to force applied plus mg sine theta minus mu mg cosine theta, all divided by mass. And again, you can't cancel the masses here. Alright, now let's just look at the diagram one more time. This is force of gravity. That's the parallel force. The parallel force is parallel to the inclined plane, and it acts downward because gravity is acting downward. And so these are component forces downward here and downward there. And if you follow your vector rules, force of gravity would be a resultant vector. Okay? Force of friction is in the upward direction because it's opposing the applied force, and that's pretty much that